Yeah, welcome to this lesson. And in this lesson, we'll be treating Introduction to Atomic Structure. So, first off, atomic structure is the foundation of chemistry and it refers to the composition and the arrangement of particles within an atom. So, when you hear the word atomic structure, you're talking about what the atom is made up of, the different building blocks of an atom. And from studies, we've been able to find out that the basic components of every atom is the proton, the neutron, and the electron. So, but in general view, they are just seen as two portions, the nucleus and electron. So that's what it is. That's what is seen as the main structure of an atom. Is just made up of a nucleus and the electrons. But when you zoom in deeper, you'll find that the nucleus is made up of two other subparticles, and these particles are known as the proton and the neutron. So going forward in this lesson, we'll be having a deeper understanding of this atomic structure. So let's see. First, from history, the concept of atom began with a Greek philosopher known as Democritus. So this guy was one of the first person that proposed the existence of indivisible particles, which he called atoms. So as time went on, another scientist known as John Dalton, he studied and found that there were these stuffs that were called atoms truly, and these stuffs, they seem to have sphere-like shapes. So he gave propositions on some of their properties. He gave what we now know as the Dalton's atomic theory. He gave some theory trying to describe these atoms. So as other scientists began to do other discoveries on these same atoms, they started studying atoms more. Stuff people like J.J. Thomson was able to discover some other stuffs like electron, and Rutherford was also able to discover some other models known as the nuclear model, and also Niels Bohr, he was able to give the proposition of the quantization of energy in atoms. So let's see, subatomic particles. So as I said at the beginning, I said atoms generally are seen to be made up of just electrons and neutrons. But now, if you zoom them in clearly, you would see that it's not just electrons and nucleus and the nucleus that exists as the structure of an atom. So we have other subatomic particles within an atom, and these particles are known as protons and neutrons. So if you want to group all the particles present in an atom, you would call them proton, the neutron, and the electron. So it is important to know that the proton is positively charged, the neutron is neutral, while the electrons are negatively charged. Protons are positive, electrons are negative, neutrons are neutral. And also take note that the protons and the neutrons, they are found at the center of the atom. They are found in the nucleus of the atom. So two important things: the charges of each of these subatomic particles and where two of them reside. So proton and neutron, they reside in the nucleus of every atom. So the balance between these particles determines the atomic stability and also behaviors such as their chemical properties. So let's see the neutrons and the electrons. So these are the wider view of what atom structure is made up of. So the nucleus is a dense center that has a core for each atom, and it contains protons and neutrons. So this nucleus is just seen like an encasing that encases both proton and neutrons. So it accounts for most of the atom's mass rather, and electron clouds are said to revolve around this nucleus. They are said to move around this nucleus. So we have the nucleus and we have electrons. So these electrons are the ones that are seen to move around the nucleus at specific distances, specific measurable distances. Later on you will understand what I mean by measurable distances. So but they move generally around the nucleus. So in the nucleus we have two other particles known as the protons and the neutrons. So electrons within the clouds, so the electrons are said to have to move around a cloud like region about the nucleus. So electrons within this cloud occupy energy levels and shells, and they are involved with chemical bonding and also reactivity. So let's see some of the forces in an atom. We have three major forces in every atom. So the first force I'll be mentioning is the strong nuclear force. So this strong nuclear force is the force that tries to bind the protons and neutrons together inside the nucleus. So we said that the protons and neutrons, they are in the nucleus of every atom. So there is a force that actually keeps these two particles stayed in the nucleus of the atom, because normally we know that protons are positively charged, electrons outside are negatively charged. So electrons are supposed to be outside the nucleus, while protons are supposed to be inside the nucleus. So normally, from the general law of electricity, we know that like poles repel and like poles attract. So normally protons are supposed to get attracted to the electrons outside, or the electrons would get drawn into the protons inside, but for some reasons this is not happening. So the protons are being held at the center of the nucleus, and they are being held by a strong nuclear force, and this nuclear force is also what holds the neutrons in the center of every atom. So then the next force that we're talking about now, that is present in every atom, is the electromagnetic force, and this is the force that is responsible for the attraction between the electrons and the nucleus. So now this force is the force of electricity, which we talked about, that said like poles repel and like poles attract. So the electrons would want to come into the nucleus, come and meet the positive, but for some reasons they can't come in because of some reasons which I would explain later on. So these electrons, they don't just leave the surface of, they don't leave the surrounding of the nucleus, because there's a force that's trying to keep them within that region, within that cloud region. So the next force we'll be talking about is the structural, sorry, not a force, there are basically two forces. These are the two forces, the nuclear force and the electromagnetic force. So now the next thing we'll be talking about is the structural integrity. So to maintain the atom structure, these forces need to come in play. These forces, they need to come in play, and when these forces are in good balance, the atom is going to be seen to be stable and have a state like a predictable behavior. So let's see some of the importance of knowing the atomic structure in chemistry. So atomic structure tries to explain periodic trends, and it tries to also explain bonding pattern, molecular shapes, and also the behavior of elements in reactions. So this the understanding of this atomic structure is very necessary as chemists, as even students that are studying chemistry, because it can help you to be able to predict reaction outcomes, be able to predict behavior of different elements, be able to determine or tell the shape of different elements, and so on. So chemists can use this knowledge to predict chemical properties and also develop new substances with desired characteristics. In conclusion, a deep understanding of this concept of atomic structure is crucial for studying and applying chemical principles, from discovery of subatomic particles to the development of atomic models. The evolution of atomic theory has also led to the development which we now see as modern chemistry. So due to the knowledge and the understanding of atomic structure, scientists have been able to move further from the basic knowledge to what we now know as modern chemistry, and research also continues in this field to see how much we could draw out from the understanding of atoms and also their atomic structure. So with all this being said, I'll say we've come to the end of this lesson, and I'll be saying goodbye.